The following is produced by 5 Star Productions USA, which is solely responsible for its editorial content and is sponsored in part by a grant from Paul Mitchell Salon Hair Care.
Constant change, that's the state of the world. Almost every day, 250,000 people are born. 100 species are doomed to extinction. Nearly 140,000 new cars hit the road. A forest area the size of LA gets cleared, and 12,000 barrels of oil spill into the ocean. There's definite problems on this earth, and there's definite answers. Hello, I'm Ed Begley Jr., and this is Today's Environment, broadcasting from the Walt Disney World Resort near Orlando, Florida, where we are probing some of the solutions that may be changing the state of the world for the better. It doesn't seem to make sense. We live on the water planet, but fresh water is considered a precious resource, and conservation looms as a major challenge to our world. Maybe they should have called it the saltwater planet. Here's more.
Dry, parched, arid. In the desert, the sun sucks up moisture faster than you can sweat. But still, many desert communities top the list of the nation's fastest growing areas. And satisfying the ever-increasing call for water poses one of the toughest challenges for these expanding sun-baked cities. Aggressive water conservation stands out as a vital measure to help balance the nearly unquenchable demand with a rapidly shrinking supply. Some innovative programs are taking a look at past water-indulgent practices and finding ways to conserve better. This sewage treatment plant in the city of El Paso and this El Paso Electric Company power station teamed up and devised a solution to save nearly 700 million gallons of fresh water every year. The treated water from this sewage treatment plant normally would be discharged back to the environment, but now some of that water travels through a 7-mile pipeline to the power station, where it circulates in the electrical generating station's cooling towers that used to gulp many thousands of gallons of fresh water per day. The cooling towers work similar to large evaporative coolers and reduce the temperature of the water used to produce the steam that turns the turbine. The treated wastewater can be recirculated through the system up to 15 times, and it's still not ready for retirement. A 35-acre holding pond stores this lake-sized volume of effluent, which eventually gets pumped to nearby desert to help irrigate native grasses and plants used as cattle feed.
A joint research effort between the utility and Texas A&M University seeks to maximize irrigation effectiveness by identifying native desert plants that thrive with the recycled sewage effluent.
From cooling tower to irrigation, the treated wastewater replaces fresh drinking water at each stage. It helps preserve that resource which is so precious on the arid desert.
This water conservation project is a good example of how a public utility and city government can work together to find solutions to local problems within our community. We're all a part of the same city, and now we're members on the same team to ensure that our community continues to grow, thrive, and flourish.
Migrating waterfowl have discovered that the holding pond is a good stopover on their journeys across the continent.
Innovative conservation programs like this one do not have to be restricted to desert communities with severe water shortages, when you consider that the amount of water now on Earth hasn't changed since the dawn of time.
The demand for that water grows exponentially every day, so it becomes clear that water conservation is more than just an environmentalist buzzword. It may be a matter of survival. And if we can all join together in an effort to conserve, we might help keep the water planet on terra firma.
A plastic six-pack ring can be a hangman's noose for marine animals. So sniff your rings and save a seal. Get involved with Today's Environment today.
Well, here's the plan, and the thinking reflected in these designs often has an enormous impact on how a building consumes water and energy. A little forethought can prevent a lot of waste, and this next idea may help make our blueprints a little greener.
Beethoven, Bach, Mozart, some of the world's greatest composers. They knew how to merge notes, bars, and measures into a timeless symphony. But a masterpiece need not be limited to music. many modern-day architects struggle with the challenge to merge bricks, blocks, and steel into a symphony of form, function, and environmental harmony. Sustainable architecture, it's the methodology of designing structures so that they preserve our environment, and it's a trend whose time is long overdue. This gas company resource center in Downey, California, stands as a good example of sustainable architecture. Designed by architects at Wolf Lang Christopher, the form of the structure itself represents the same respect for the earth that the function of the building will foster. The walls and other building elements demonstrate the cutting edge of sustainable design innovations. Many of the building materials come from the previous structure that stood on this site, and several thousand square feet of ceiling tiles were removed before demolition and then used again. The recycled steel in the support beam contains post-consumer recycled metal. Low E-glass windows and thorough insulation will reduce heat gain and loss by half. Daylighting with indirect sunlight will cut the energy demands even further. The xeriscape gardens use native plants and grasses that thrive in the existing climatic conditions. They eliminate the need for water-ravenous sprinkling programs.
The challenge to creating sustainable architecture is to provide thoughtful and meaningful solutions which recognize the real-time everyday problems of budget and schedule and all the construction processes, but also blends in all available technologies in terms of energy savings, indoor air quality, recycled building materials, and really strives to balance good financial value with meaningful environmental accomplishment.
Proper planning at the design stage remains the key to minimizing a project's impact on the earth. Special software and design processes developed at Wolf Lang Christopher help the architects blend ecological technologies together. The design of this high school incorporates many of the same elements studied as part of the environmental curriculum, and the harmony in this complex between the structures and the surroundings stands out as another example of environmental stewardship. When humans first ventured out of the caves, they began to construct shelters solely to protect themselves from the environment. Now, we must strive to reach a higher level where we take care to ensure that our architectural structures protect us and preserve nature. And if we can orchestrate this balance, our new compositions will bring us more in concert with the earth. Next on today's environment, the latest contamination containment methods hit the trenches and a high-tech approach to help turn the tide in the war against toxic soil.
The only thing constant is change. Everything in the world is moving and changing all of the time. That includes pollution. It travels and it changes form, which can compound the problems. This next idea may be a way to help keep it in one place.
Wise generals often say a great battle is won in the trenches. And right now, the entire planet is involved in a war against pollution where the fate of the Earth could hang in the balance. Now, the enemy respects no battle line and attacks the health and well-being of all living things at nearly every coordinate on the globe.
Figuratively, the trenches in this war include every point on the planet. But literally, an actual trench can help prevent the migration of contaminants and isolate them for a more efficient cleanup or containment effort. One method used to contain the horizontal migration of hazardous chemicals spilled into the soil and to prevent contamination of the groundwater is the installation of an underground vertical barrier called a slurry trench. This slurry trench, installed by Inquip Associates, helps create a real barrier to chemicals leaching horizontally across this contaminated site. In the conventional slurry trench method, as the excavation proceeds, the trench is kept full of slurry made by mixing water and bentonite. The bentonite slurry seals the pores of the adjacent soils and applies some hydraulic pressure on the walls of the trench, which prevents them from falling in. This eliminates the need for physically shoring up the sides, and more importantly, no one needs to go down into the trench. A specially designed backhoe can dig a 2 to 5 foot wide trench to depths of 80 feet. Other specialized equipment like a crane with a clamshell device can create or deepen an equally wide trench all the way down to 300 feet. After excavation, the trench is generally backfilled with an impervious material to create a vertical barrier or cutoff. In this case, the bentonite slurry is mixed with the excavated soil, and the resulting impervious mixture is returned to the trench. Other backfill materials can be special cement-based slurries or concrete. Often these trenches are installed around the perimeter of a landfill and keyed into an impervious clay layer below. The wall prevents horizontal flow of the contaminants, and the clay layer prevents their downward migration. These walls can isolate areas where chemical spills threaten to spread into underground aquifers and contain the area that requires remediation. In one innovative use of slurry trenching, INQIP created a barrier that channels contaminated groundwater and migrating pollutants into a filter hidden deep in the earth. In other applications, a biopolymer instead of the clay-like mineral bentonite is used because the polymers will biodegrade over time. This means the wall will remain impervious for only a period of time, and then the soil will return to its original permeability. The trench is then backfilled with pervious gravel, resulting in a collection trench to extract contaminated groundwater for treatment. The war against pollution rages down in the trenches, and now with this innovative application of construction technology, we may be able to slam contaminants right up against the wall and open the door for a cleaner tomorrow.
If fish could talk, they'd be mad as hell. Every year, 14 billion tons of trash get dumped in the ocean. Bring litter back to the dock and recycle it. Get involved with today's environment today.
Is it a blessing or a curse? One of the fastest growing sectors of our economy is hazardous waste remediation. The bad news is we need it. The good news is there are many innovations to help with this cleanup, and this may be one of them.
It's out there, but you can't see it. Somewhere under all this ground, toxic hydrocarbons leach through the soil and won't stop until they reach the groundwater. You could use the hunt and peck method, random drilling and sampling, to locate the contaminants, but that takes a lot of time and plenty of money, luxuries we don't often have. Because when gasoline, jet fuel, diesel, or other organic contaminants leak out of faulty storage tanks and into the soil, that contaminated patch of earth threatens our health, the environment, and especially our groundwater. To complicate the cleanup of that dirt, the process of drilling and sending soil samples to a lab for analysis used to be the only way to characterize the extent of the pollution and the migration of the contamination. And after drilling for all those samples, the environmental scientist was often left frustrated and confused about the true nature and extent of the problem. But now, a new technological tool may help us turn the toxic tide in our war against soil contamination. This rapid optical screening tool, ROST, developed by Unisys in alliance with corporate, government, and academic institutions, is carried aboard a cone penetrometer truck, or CPT. The CPT provides a view of the soil stratigraphy and composition. The ROST, tunable laser-based detection system, can identify the aromatic hydrocarbon-based pollutants and their migration. Using fewer and more precise drillings, it can create a more accurate 3D picture of the contamination underground. A cone penetrometer test probe with a sapphire window pierces the soil slowly and releases a laser light. The wavelength of the light can be varied to allow detection of various aromatic hydrocarbons. Different hydrocarbons absorb and reflect light at different frequencies, and special sensors record this activity. The information goes directly to a highly automated detection system controlled by an operator inside the truck who monitors in real time the data being collected, processed, and analyzed.
The advantages of the ROST system is that it eliminates the need for much of the soil sampling and drilling, which is both difficult and expensive. And it lets us get data in the field much more quickly so we can decide what kind of problem we have and where we have it. And it's less expensive. It lets us get on with the remediation instead of spending a lot of time and money in the analysis phase.
Currently, Unisys researchers are working to expand the system's capabilities so it can identify other types of pollutants like chlorinated solvents and heavy metals. If a laser can help us look into the ground and see what's going on below the surface, it may open our eyes to the mistakes of the past and give us a new vision to help guide us in the future. In a moment, newly enacted safe manufacturing processes and their significant impact on our world. Plus, the daily paper takes aim at their own liquid hazardous waste.
If you want anything done right, you have to do it yourself. Businesses and governments don't take action, people do. An organization behaves according to the individuals within it. they choose to act responsibly, their organization will too. Here's a closer look.
Good morning, Ms. Phelps. As you know, our planet faces serious threats to its land, water, and air. The adversary, pollution, from the way we live. Your mission, should you choose to accept it, is to protect the world from environmental degradation. Should you not accept the mission, life as we know it could be threatened. Save the Earth. Is it really a mission impossible? It's a formidable task, but we have the means to heal the planet. Now we need the will. Individuals and organizations must join in a global effort to preserve the Earth for tomorrow. Some organizations are already trying to answer the challenge, and IBM is one such company, working to protect the environment through the design of its manufacturing processes. The technicians in this clean room help produce microprocessors. Manufacturing these computer chips used to require chlorofluorocarbons, or CFCs, substances thought to damage the Earth's ozone layer. But environmentally responsive programs modified processes and developed alternatives to eliminate CFCs. Constant review also seeks to eliminate hazardous chemicals or reduce their use and substitute them with less hazardous ones. The results of these programs are significant. Since 1987, chemical air emissions worldwide have been reduced 90% and hazardous waste has decreased 63%. But environmental scrutiny does not stop at manufacturing processes. These engineers spend nearly as much time thinking about how to take their computer apart as they do wondering about how to put it together. Planning for a product's entire life cycle means designing energy-efficient machines that disassemble easily to facilitate reuse, recycling, or proper disposal. It requires incorporating recycled materials, using recyclable parts whenever possible, and reducing packaging waste. Being environmentally sensitive in the design and manufacture of computer hardware allows the company to operate in a more sustainable manner. Developing software and applying the technology to help solve environmental problems, however, puts them at the front line in the war against pollution. 14 IBM technology grants target research on specific challenges facing our world today. Advanced simulation and visualization techniques help solve problems like the conservation of biological diversity, optimizing groundwater remediation, and protecting coral reefs and mangrove ecosystems. Other projects are working to preserve the tropical rainforests of Amazonia. At times, the environmental problems plaguing the planet may seem overwhelming, but when individuals, organizations, and governments all accept the challenge to create a more sustainable world, a mission impossible can become a mission accomplished.
If you don't recycle your newspapers, you might just as well be wielding a buzzsaw. The Sunday issue of the New York Times alone requires between 60 and 75,000 trees. These headlines don't have to ruin the tree line. Here's a good example.
The power of the press, America's fourth estate. It could cover brilliant events or expose shady ones. But the very forum that gives the press its power could be sapping our environment of its strength.
Enormous amounts of raw materials go into printing the pages that bring us the news. On any given Sunday, this one newspaper that once helped support the election of Abraham Lincoln devours 40 tons of newsprint, 600 pounds of black and color ink, gallons of chemical developers, miles of plastic films, and many pounds of silver-coated photographic papers. Some newspaper publishers, like the ones at this daily, the Springfield, Illinois State Journal-Register, feel that they owe their readers more than just good journalism. They're making a major effort to make sure that their operations achieve environmental excellence. Reducing their liquid hazardous waste became a top priority, and they found soy-based inks to replace their hazardous solvent-based colors. All photo processing and developing stations are now equipped with silver recovery tanks and filters that help recycle the chemicals. Aluminum printing plates get used, then recycled, and an innovative filtration system has reduced waste press oil from over 200 gallons a year to nearly zero. Preventing newspapers from ending up in a landfill is one of a newspaper's biggest challenges. But with a closed-loop recycling program, the pages of this daily come from 40 to 45% recycled newsprint. A vital part of the plant's everyday operation includes collecting old newspapers and baling them for the recycler. The truck that brings in fresh recycled newsprint actually takes out yesterday's news for reprocessing. Sources at the State Journal-Register, a Copley-owned newspaper, say that new computerized publishing software will dramatically reduce their waste paper from layout and production. They also feel that their programs to improve environmental performance did not compromise their high-quality reproductive standards.
Newspapers bring us in-depth coverage of events, special features, and a forum for ideas that goes beyond the constraints of the electronic media.
Freedom of the press is more than simply a democratic concept. It's our constitutional right. And through diligent environmental practices, now we can exercise this inalienable right without alienating the planet.
The next time you start to throw away an aluminum can in your trash instead of your recycling bin, consider this. Throwing away an aluminum can wastes as much energy as if you filled it half full of gasoline and poured it out. It takes 10 times as much energy to produce aluminum from virgin ore. Here at the Walt Disney World Resort, they know that empty cans are a valuable resource. Please recycle them. I hope this show gave you some other good ideas. Join us again next time as we explore more environmental solutions on Today's Environment.
Epcot 95 is located at the Walt Disney World Resort near Orlando, Florida. Accommodations provided by the Buena Vista Palace, Walt Disney World Village. If you know of any interesting environmental success stories, call us at 407-997-9800. The preceding program was sponsored in part by a grant from Paul Mitchell Salon Hair Care. This has been a presentation of 5 Star Productions USA.